So we have a math counts problem today. So this was a target problem in the national test. So I guess it was number 6. So target number 6 national is kind of challenging. So let's see what we have. So we are given that n is larger than 1. What is the smallest number that those positive divisors have a product of n to the 6th power? So like the question itself is not actually easier to understand. We have a number that we are looking for, so that will be just number n. And then when you find the divisors, you multiply the divisors, and the divisors like product will be equal to the number to the 6th powers, which is kind of interesting. And then we just want to find the smallest number that will work with this condition. So we can go ahead and start testing some smaller values until we get the correct one, but maybe you never get that number immediately. So which is why it may not be the best shot to do so. But what I will try is like to use a kind of approach to find the product of the divisors, because we know how to deal with the number of positive divisors if you kind of don't know that either. So you probably need to go back and review that before you move on to this problem. So we want to find the number of divisors. What we did was, in that case, was we write the prime factorization and use that prime factorization and write all the divisors in terms of prime factorization. And then by using that, all the divisor in terms of prime factorization, we were able to get a general kind of approach to count the divisors. And then with the similar reasoning, we actually did the sum of the divisors as well. But now this is actually asking the product of the divisors. So, but before we get into a general form or general expression, I don't want to name formula. I will kind of make an example, kind of see what's going on. I'll just choose 18 for the sake of simplicity. You can take maybe 8 or 12, anything that you like. But this is 3 squared times 2, right? So what I'll try is I'm going to write the product of the divisors. So we have 1, 2, 3, and 6, 9, and 12. So just remember, if you want to find the number of divisors, so which we sometimes use t of 18, so this is going to be equal to 1 more than the power of h prime, and then multiply those, right? So 2 plus 1 times 1 plus 1. Again, if you don't really remember this, so get to review for sure. So because any prime number could have 0th power, 1st power, or 2nd power in this case. And then this 2 could have 2 to the 0 or 1. So you just have 2 different power of 2s and 3 different powers of 3. So that's why 6 divisors. So which is 1, 2, 3, 4, 5, 6. And then what I'm going to try now, I'm going to write these numbers backward. So which is, actually this was 12 is not the case, right? So this has to be 18. So this is 18. And then I'm going to rewrite these 18, 9, 6, 3, 2, and 8, 1. So the reason why we are going to do, I'm going to multiply these equations. So that will give us p times p, which is p squared. And these 2 is going to be 18, these 2 is 18, these 2 18, these 2 18, these 2 18. So we have 18, but how many times do we have those 18s? We have, in this case, 6 times because we have 6 divisors. So the number of 18s is actually the number of divisors. So in this case, it's 6. So if I want to make this in like p alone, which is the product of the divisors, so the p would be square root of this, which I can take the 1/2 power of each part of the number, so which will give us p equals 18 to the 6 over 2. So I just want to rewrite like this way because I don't want to write the 3 immediately. But this is like what's going on. Do you see some nice relation? The p represent for the product of the divisor, that's equal to 18, the number that we start with 18, to the 6 over 2. 6 is the number of divisors, and that is going to be divided by 2. So that is actually always the case. This is not a coincidence, because in this problem, I just got 6 divisors, and then that will give me this. When you rewrite this, you just have 6 of those 18s. So if you have some different number of divisors of that number, then you will get that many product. So which is why the number itself to the power is going to be number of divisors that's equal to p squared. So p squared will be always the case because we just rewrite the equation. So that means if you want to make this in general, so let's say we have a number n, right? So let's say this is equal to so p1 to the some exponent, okay, p2 to the some exponent. So these are just the prime numbers as a divisor. So let's say pn to the en. So of this, the number of divisors, I'm going to use T of n is equal to b1 plus 1, b2 plus 1, which is these exponent. And if you keep doing this, that will be en plus 1. So that was the number of divisors, right? But what we want to do now is the product of the divisors. So the product would be, you just rewrite these guys, whatever number of divisors you have. So this is the total number of divisors. When you rewrite these guys, then you actually gonna get the product, which is gonna be like the number itself, in our case n. So n to the power of, like, power will be divisors, the number of divisors, but this is gonna be p squared when you multiply this twice. So that should be T of n. And if I take the square root, so the product is gonna be n to the T of n, which is the number of divisors, over 2. Again, this is a good one to remember. I wouldn't say memorize, but it is one of the powerful relation we have with the divisors. So again, we have the sum of the like divisors, we have the number of divisors, now the product of the divisors. Okay, so how this is gonna be useful, right? So we want to find the number, smallest number, let's say that's n. This will be equal to, the product will be n to the 6th power. So how do you find that? So we do have like T of n, which is the number of divisors, over 2. This will be the product of the divisors. And then we are told this is n to the 6th power. So if that's the case, the power has to be same. So the T of n has to be 12, meaning that the number that we are looking for should have 12 divisors. And the question is, what is the smallest number that has the small, like 12 divisors? So if you have 12 divisors, so the 12 can be written as 12 itself, right? Or like 6 times 2, or 4 times 3, or 2 times 2 times 3. I don't want to write some other ones as well, because like I can write once, but it doesn't work. Because when you find the number of divisors, we take each exponent, if you remember like that, we add 1 to each exponent and multiply. So when you do this, the result should be 12. So meaning that if you have only one prime number, so you could have a prime number to the 11th power. So that could be one way to get 12 divisors. Or if you have two different numbers as a prime factor, so you could have p1 to the 5th power times p2 to the 1st power, because if you increase these by 1, you get 6 and 2. So when you multiply, you got 12. Or you could have 4 and 3 after increasing by 1. So you can have p1 to the 3rd and p2 to the 2nd. Or the last one would be p1 and q1 and r. I should probably say p's, right? So p's, because I just use p's. So p1, like prime 1, and then p2 and p3. So since we want to get 2, 3, and 2, so that should be 1, 1, and 2. And of this, we want to choose a smallest one, which means we want to use the 2s and 3s if needed, or 5 at most. So the smallest power is 2 to the 11, which 2, so that should be like 2048, which is a huge number already. And then if you want to get the smallest one, I will choose p1 as 2, so 2/5 times p2, which is going to be 3 smallest. That should be 96, which is way smaller. And the next one is p cubed, so I'm going to choose 2 cubed and 3 squared. So that's going to be 9 and 8, which is 72, which looks like a bit better. And the next one is I will choose 2, but I want to choose 2 for this guy to make the smallest. So that should be 3, 5, and 2 square. So that will be 15 times 4, which is actually way smaller than the others. And then this is the smallest I can make. So if I choose number n as my 60, then when multiply the divisor of 60, you actually get the 60 to the 6th power of the product. So that means our smallest number is going to be 60. So I hope that was clear. So I took a bit longer just to explain how we got this, I would say, expression to find the product of the divisors. So if this was clear, so I hope that is. So that is really useful. If not, then go ahead and try slowly digesting each step, and even maybe review some of the divisors and the counting divisors, like the number of divisors, because those are also some backgrounds that will be useful to understand this one. But anyway, so I'll see you in the next video.